of skewness, and second one will be coefficient of skewness. Okay, so let us start with what is what the skewness means. So meaning of skewness is lack of symmetry. Okay, lack of symmetry. Okay, and why we study skewness? We study skewness to have an idea about the shape of the curve, the shape of the curve, okay, which we can draw with help of which we can draw with help of given data. Okay, and a distribution is said to be skewed is said to be skewed when mean, median, and mode fall at different point. Okay, so this means mean not is equal to median and not is equal to mode, or this is first point skewed first, and the second point is, ठीक है वेट करने दीजिए, quartiles are not equivalent from median. Okay, and third point is the curve drawn with the help of data is not symmetric. The curve drawn with the help of data is not symmetric. Okay, so this is now how we can measure the skewness. So various measure of skewness are, say for example, some measures of skewness of
सर कोई ज्वाइन होना चाहती है?
ओके, तो वेट करने दीजिए, मैं बार बार ज्वाइन नहीं कराऊंगा ना, मैं जब मुझे लगेगा। तो स्क्यूनेस जो होता है वो कई साइड टाइप का होता है. दिस इज कॉल्ड पॉजिटिवली स्क्यूड एंड दिस इज कॉल्ड नेगेटिवली स्क्यूड. Okay, so जिस जिधर डिस्ट्रीब्यूशन का टेल रहेगा वही स्क्यूनेस होगा. दिस इज पॉजिटिवली स्क्यूड and this is negatively skewed, and this curve is as it looks symmetric. Now let us discuss the few measures of skewness. So positively skewed में क्या होता है? Okay, इसको बाद में डिस्कस करेंगे. What is positively skewed and negatively skewed? And so measures of skewness is SK is equal to mean minus median. दूसरा मेजर है mean minus mode, where M is mean, this is median, and this indicate mode. Okay. Another measure of skewness based on quartile deviation is SK is equal to Q3 minus median minus of median minus Q1. So as you know, Q1 and Q2, Q3 are Q1 and Q3 are first and third quartile. So and these three are absolute measure of skewness. Okay. So, but we are also interested in relative measure. So we may also interested in relative measure called the coefficient of skewness. रिलेटिव मेजर में हम लोग क्यों इंटरेस्टेड होते हैं? क्योंकि रिलेटिव मेजर जो होता है उसको हम लोग वो यूनिटलेस क्वांटिटी होता है. दिस रिलेटिव मेजर इज ए यूनिटलेस क्वांटिटी. This one is this one is unitless. Okay, and it can be used to compare two data sets. इसको हम लोग यूनिटलेस क्वांटिटी होती है, इसका यूज हम लोग कंपेयर कर सकते हैं टू डेटा सेट्स. सो फर्स्ट मेजर ऑफ स्क्यूनेस इज sorry, it is coefficient of skewness is Carl Pearson coefficient of skewness, and it can be defined by mean minus mode divided by sigma. And there is an empirical relation between mean, median, and mode, that mode is equal to 3 median minus 2 mean. This is an empirical relationship between, this is a relationship. Okay, and this using this relationship, coefficient of skewness can be defined as 3 mean minus median by sigma. Okay, so for positive skewness, skewness mean is greater than mode. Okay, or mean is greater than median, and negative skewness mean is less than mode, or mean is less than median. And for symmetric curve, mean is equal to median is equal to mode. Okay, so this is a relationship with, in between mean, median, and mode for skewed and non-skewed curve. Now there is one more coefficient of skewness. This was Carl Pearson coefficient of skewness. You should remember this. Next coefficient of skewness is Professor Bowley coefficient of skewness, and we can define it as Sk is equal to Q3 plus Q1 minus 2 median by Q3 minus Q1. Okay, and it is also known as this one is also known as quartile coefficient of skewness. Okay, so this is this was all about Bowley's coefficient of skewness. Next is before defining other coefficient of skewness, let us define some beta and gamma coefficient. Okay, so beta coefficient Pearson. Let us define Pearson's beta and gamma coefficient. So this is an important concept. So Carl Pearson defined 4 coefficients based on, he defined it defined four coefficients based on moments, and these four coefficients are beta 1, it is mu 3 square upon mu 2 cube. So you can visualize that these coefficients are unit list, and gamma 1 is equal to positive root of beta 1, and there is beta 2, it is mu 4 upon mu 2 square, and gamma 2 is equal to beta 2 minus 3. Okay, so these are four coefficients based on moments. These are these
सर बीटा
coefficients
टू
are
सर बीटा टू इक्वल टू सर वो क्या होते हैं?
mu 4 upon mu 2 square.
ओके सर.
ओके, मैं चेंज कर देता हूँ, mu 4 upon mu 2 square. Okay, these coefficients are pure numbers and independent of units of measurement. So all four coefficients are pure numbers and independent of unit of measurement. Okay, now based on these coefficients, coefficient of skewness can be defined as, so based on moments, coefficient of skewness can be defined as Sk is equal to under root beta 1 beta 2 plus 3 under root beta 1 beta 2 plus 3 and 2 times 5 beta 2 minus 6 beta 1 minus 9. So this is a definition. So in this case, Sk, the skewness will be 0. Sk will be 0 if and only if either beta 2 will be 3 or beta 1 will be 0. So it will be symmetric, either beta 2 will be 3 or square root of beta 1 will be 0. So beta 2 cannot, beta 2 is equal to minus 3, sorry, it will be 0 if beta 2 is equal to minus 3 or beta 1 equal to 0. But you know, beta 2 is in the form of xi minus x bar whole square divided by something. So it cannot be 0. Okay, beta 2 is basically based on this part. So it cannot be 0 because it is power 4 and it is power 2. So it cannot be 0. So Sk is equal to 0 if and only if beta 1 is equal to 0. So uh, for symmetric distribution, beta 1 must be 0. Symmetric distribution, beta 1 equal to 0. Okay, this was all about skewness. So next we will move to kurtosis. Okay, so what is kurtosis? Kurtosis enables it us to have an idea about flatness or peakedness of frequency curve. It is measured by coefficient beta 2 or gamma 2. It is measured by coefficient beta 2 or gamma 2, which is also is equal to beta 2 minus 3. So there are three type of kurtosis. One is a peaked curve. The second is normal curve this way, and third one is flat curve. So this is known as lactokurtic. This is known as normal curve, and this is known as this is flat. One is known as it's almost platykurtic. Okay, so lactokurtic, normal curve, and platykurtic, and it is determined by beta 2. So for normal curve, so I'm writing it point wise. Normal curve, what should be value of beta 2 and what should be value of gamma 2, which is equal to beta 2 minus 3. For normal curve, beta 2 will be 3 and gamma 2 will be 0. For lactokurtic, curve, beta 2 should be greater than 3 and it should be greater than 0. Obviously if it will be greater than 3, it will be greater than 0. And third one is which is known as platykurtic curve. it should be less than 3 and it should be greater less than 0. So you should remember this table. The value of beta 2 and gamma 2. Okay, so this was all about kurtosis. And one thing you should remember, these kurtosis are coefficient of kurtosis. Okay. And so this we have discussed all about univariate data, properties of univariate data when only one variable is involved. Now we will discuss about multivariable, more than one variable. When more than one variable, we study more than one variable. So we'll and when studying more than one variable, we should first consider the relationship among variable, whether two or more variable are related internally or they are not related internally. If they are not related internally, then you can study these variable by assuming two different variable, and you can by taking separately taking these two separately. Okay. But if they are related in some or other form, then you should go for finding these relationship. Okay. So first type of relationship is linear relationship, and the measure of linear relationship is known as correlation. And so today we will start correlation. Okay. So let us start correlation. So in bivariate distribution, distribution, we may be interested in, find out if there is any correlation between two variables under study. If there is any correlation between the two variables under study. So what is correlation? So correlation is quantitative measure of relationship between two variables. Quantitative measure of relationship between two variables. Okay, and obviously there are two types of correlation. First is positive correlation and second is negative correlation. Other definition of correlation is can be given as if change in one variable affects the change in other variable, affects the change in other variable, the variables are said to be correlated. The variables are said to be correlated. Positive correlation, if 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 increase or decrease in one variable results to corresponding to corresponding increase, decrease in other. So this results to positive correlation. Similarly, if increase, decrease in one variable results to corresponding decrease, increase in other. So it is known as negative correlation. Say for example, income, let us see some example. Income and expenditure is positively correlated. Is positively correlated. Volume and pressure of a perfect gas is negative. Volume and pressure of a perfect gas is negatively correlated. Next is scatter diagram. So scatter diagram, it is a diagrammatic representation of of bivariate data. So suppose your observation are x1, x2 up to xn, and corresponding value of y1, y2 up to yn. So you can plot like this. This point will be x1, y1. Similarly, this point may be x2, y2. This point may be x3, y3. This point may be xn, yn. So this is basically your x-axis and this is your y-axis. So this is a scatter diagram. So values of xi and so what we do, values of variable x and y are plotted along values of variable x and y are plotted along x-axis and y-axis, x-axis and y-axis respectively. In the xy plane. The diagram of dots obtained is known as scatter diagram. The diagram of dots obtained is known as scatter diagram. Okay, next we will study Carl Pearson coefficient of correlation. So Carl Pearson coefficient of correlation. Again, it is a unit free quantity. So given by a British mathematician Carl Pearson. Okay, and this correlation coefficient between two random variable x and y. So correlation coefficient between two variables x and y are usually denoted by r of x comma y and can be defined as r x comma y is equal to covariance of x comma y and sigma x sigma y. and where covariance sigma x sigma y is standard deviation of variable x and standard deviation of variable y, and covariance of xy can be defined as, if you have studied expectation, you can understand covariance of xy can be defined as expectation of x minus expectation of x and expectation of y minus expectation of y. Okay, so basically x bar is nothing but expectation of x and y bar is nothing but expectation of y. It is basically estimate of expectation of x, and in term of summation it can be expressed as xi minus x bar and yi minus y bar, and which is also called mu 1 1. Okay, and sigma x is obviously sigma x is nothing but 1 by n summation of xi minus x bar whole square and this whole to the power half, and similarly sigma y is equal to 1 by n summation of yi minus y bar whole square and this power half. So this is basically, now this covariance of x can be also expressed as 1 by n summation of xi minus x bar and yi minus y bar, and this can be further written as summation over xi yi minus xi y bar yi minus yi x bar plus x bar y bar, this whole divided by n. Now if you again do some manipulation, it can be expressed as y bar summation of xi upon n and x bar summation of yi upon n and plus summation of x, sorry, it should be summation of x bar y bar upon n. Since x bar y bar are not varying over I, so what we can do, we can say x bar and y bar are constants because they are not varying over I. Now what next we can do, summation of xi yi, this is nothing but, this part is nothing but x bar and this part is nothing but y bar, so it will be y bar x bar minus x bar y bar, and this is this part is nothing but n x bar y bar upon n, so it will be okay. So this sorry, it is not x bar. So this, so covariance of this xi yi can be written as this, and resulting correlation coefficient can be obtained by this. Okay, so now let us come to scatter diagram. Okay, if your scatter diagram is like this, okay, this is x-axis, y-axis, then r of x comma y is said to be positively correlated. If this x bar y bar is like this, then r of x comma y is negatively correlated, and if this x bar y bar is like this, there is no correlation, and if if xi yi fall on a line, then r is equal to -1. And if xi yi is like this, and this is r is equal to +1. If they fall on line, it is called r is equal to plus or -1. It is called perfect correlation. Okay, so it is known as perfect correlation. Okay, so next we will discuss in next class, we will discuss limits of correlation coefficient. So limits of correlation coefficient is r is varying from -1 to +1. Okay, so this is limit, but we will also derive its limit. Okay. So +1 is called perfect for negative, and yes, perfect. -1 is called perfect negative. Perfect negative, and this is called perfect positive. Okay, so this is basically the limit of correlation coefficient, and we will derive this limit. Okay,
सर सर परफेक्ट का मीनिंग इस कोरिलेशन में नहीं समझ में आ रहा है।
परफेक्ट का मीनिंग मतलब कि कोरिलेशन एकदम परफेक्ट है, +1 है या -1 है, इसी का परफेक्ट मतलब कि सारे जो डेटा पॉइंट्स हैं वो एक लाइन पे फॉल कर रहे हैं, एक ही लाइन पे फॉल कर रहे हैं। एक लाइन का जैसे इक्वेशन आप जानते हो, x = y ax + by + c = 0, इस तरह किसी एक लाइन पे फॉल कर रहे हैं सारे पॉइंट्स।
मतलब सर लीनियर है तो परफेक्ट है।
यस, एक लाइन फॉलो कर रहे हैं तो परफेक्ट है।
ओके सर।
Okay. So I'm stopping here. I may take one class tomorrow. Okay.
Thank you, sir.
Okay, sir. Thank you, sir.